All right, let's do a little review to get you ready for the short acid-base pH neutralization quiz. So first one is just knowing some properties of acids and bases. So true or false? Both acids and bases have a bitter taste. That's false. We know that bases have a bitter taste. Acids taste sour. Letter B, both acids and bases are corrosive. That's true. They both are damaging to the skin. Letter C, acids are electrolytes, meaning they conduct electricity, but bases aren't. That's false. Both acids and bases have ions dissolved in solution, so they're both electrolytes. Letter D, acids have a pH greater than 7. That's false. We know acids have a pH smaller than 7. What's the name for something that changes color in the presence of an acid or a base? That's an indicator, like phenolphthalein, universal indicator, pH paper, cabbage juice. Sorry, Mr. Perfect, my cat. And by the way, it's spelled P-U-R-R-F-E-C-T, perfect. He wants to be part of this video. All right, number 3. Is CH3CH2NH2 most likely an acid or a base? This is most likely a base. Remember, acids typically start with an H, like HCl or HF. Those are acids. And bases typically end with OH or something like this one where they'll end with an NH2 and NH3. So ending with an H is oftentimes the base. Number 4. You come across a highly concentrated flask of acid. What are 2 things you could do to make the acid safer? 1, you could add base. That is the number 1 thing you can do. Adding a base will neutralize it, meaning it'll bring its pH closer to 7. You also could dilute it. You could add it to a bunch of water to weaken the acid. Number 5. According to the Bronsted-Lowry theory, complete these reactions. Bronsted-Lowry theory says that bases accept a hydrogen and acids donate a hydrogen. Alright, so the trick to these is don't look at the water molecule. Look at the other substance and figure out, is it an acid or a base? Because remember, water is neutral, but it can act as an acid or a base depending on what it's interacting with. So water itself is neutral. So HNO3, that's an acid because it starts with an H. So it's going to donate a hydrogen to H2O. So this is going to be NO3, and it gets a negative charge because it lost a hydrogen. And now it's going to be H3O+. And that should scream to you acidic solution. Now pH3 ends with an H, so it's going to accept a hydrogen from a water molecule. So that will be pH4+, and now that an H was ripped from H2O, all that's left is a hydroxide, which should scream to you basic solution. Number 6. What's the pH of a solution if the hydroxide ion concentration is 1 × 10⁻⁴? Well, that means that the pOH is 4 because it will match that exponent. It's a logarithmic relationship. And since you know that pH plus pOH always equals 14, if the pOH is 4, that means the pH must be 10. So that's the answer to number 6. How about number 7? Wow, this is a lot of zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that's 1 × 12. Because it's always the number of zeros plus 1. So the pH of this would be 12. A solution has a pOH of 2. What's the hydroxide ion concentration? 1 × 10⁻². Or 0.01 molar. Either way, you can write it. It doesn't matter. Is it an acid or a base? Well, let's think about it in terms of pH. The pH here would be 12. That's a really high concentration of hydroxides, so it makes sense that this is a base. Using words or a picture, explain the difference between a strong acid and a weak acid. A strong acid, let's call it HA, completely dissociates in solution, meaning all of the H's and A's will break apart, leaving those hydrogen ions in solution. Let's draw one more. H plus, A minus. So there's 3 H pluses. Here's my weak acid. Let's call it HB. HBs do not completely dissociate. So maybe we'll draw one of these that dissociated. Number 10 is a neutralization reaction. Double displacement. Mg is now going to be with Cl. Mg's got a +2 charge, so this becomes MgCl2. And H is going to be with OH. So in order to balance this out, we need a 2 here and a 2 there in front of the HCl. What if you've got a neutral solution of salt water, or like salt water? pH is 7, pOH is 7, hydrogen ion concentration is 1 times 10 to the minus 7th, and the hydroxide concentration is 1 times 10 to the minus 7th. Sorry, this 7 here is a little bit hard to see. Oops, let me make this better. There we go. What happens when an ionic base, such as LiOH, is dissolved in water? Ionic things break apart, so this will form Li plus and OH minus. The polar water molecule will pull those ions apart in that ionic bond. Optional challenge. Of course we want to take on the challenge. You want to make 2 liters of a solution that has a pH of 5. For the record, that's a concentration of 1 times 10 to the minus 5th. If you have a solution that has a pH of 2, 1 times 10 to the minus 2, describe how you could make the new solution. This is clearly an M1 V1 equals M2 V2 question. So molarity 1. We want to let's make this the stock solution. So we've got a 0.01 molar solution. We don't know how much of it we need yet, but we know we want a 0.00001 molar solution, and we want 2,000 milliliters of it. I changed liters to milliliters for the dilution question. You don't have to. Now I'm going to divide both sides by 0.01 to get V1 by itself. V1 is 2 milliliters. So what that means is I need a 2-liter flask, so that line is 2 liters, and in this I'm going to put 2 milliliters of the concentrated solution. Okay, I just drew like a little blurb of it. And then I'm going to fill to the line with water. I'm going to mix it up. This concentrated stuff is going to mix throughout, and now I'm going to have, instead of a 0.01 molar solution, when I mix all of this together, I'm going to have a 0.00001 molar solution. Alright, hopefully that helps you get ready for the short quiz tomorrow.